Observe the movement of this leg reduced to two segments. Here is the path of the hip, in red, the knee, in yellow, and the hand of the leg, let's say the foot, in green. Here is the trace of the animation. We call a trace the image showing the successive positions of a movement. Here we can see that the positions of a segment follow one another distinctly. There they overlap. When they overlap, we can see a line, here in pink, which is not the path of a particular point, but on which the edge of the segment rests each time a crossing occurs. This line is a tangent curve. It ends when the different poses of the segment no longer overlap. To simplify matters, we will call this curve a tangent to the movement, or even more simply, a tangent, because it touches the segment during its movement without crossing it. This is a simplification of language, knowing that in mathematics, the moving segment is tangent to the curve, not the other way around. Here is another one. Now, let's look at this important point. The tangent to the leg begins with the path of the foot and merges with the path of the knee. The tangent is just a particular path. A simple or extremity path guides positions that follow one another, while a tangent guides positions that overlap. The way in which these crossings occur influences the shape of the tangent. It all depends on the relationship between the moving and rotational speed of a segment. Depending on the situation, the tangent will draw a more or less tense curve and will sometimes be reduced to a simple pivot point. Not all movements necessarily involve crossings. Here is a walk that has none, and therefore no tangents. Walks and runs present at least 5 opportunities for crossings. Crossing of the thigh phases at the moment of cushioning, and at the moment of propulsion. Crossing of the leg phases at the beginning of the swing, of the leg and thigh at mid-swing, then at the end of the swing. These 5 diagrams show portions of a traveling cycle. If the cycle is in place, other crossings occur due to the backward movement of the leg during support. All of these scenarios may or may not occur during a step. Each gives the cycle its own character, either in isolation or in combination with others. Here is a walk cycle that has a single tangent at landing in the traveling cycle. Its in-place version has 2 more. It is the swagger of a bully. This other walk cycle has a single tangent during propulsion and 2 more in its in-place version. This walk is recommended when the ground is uncertain. Here is another walk cycle that has only 1 tangent when the foot is lifted, both in its traveling and in-place version. This cycle may seem strange, but it allows you to wipe your feet as you walk. This one has only 1 tangent in the middle of the swing. As with the previous walk, the in-place version adds no tangent. This walk cycle, known as the kickback walk, is very useful if someone is following too closely when walking in single file. Here is one that has only 1 tangent at the end of the swing, both in its traveling and in-place version. You can tell this one's determined. Let's combine the crossings we have just seen. First, those produced during the support phase. Does it not remind you of a cabaret dancer entering the stage? This one combines the crossings produced during the swing. Surely a majorette juggling her baton trailer. And here is a synthesis of all the crossings. In fact, by making more complex walk cycles, we can add as many crossings as we want. Simple enough, isn't it? We can try the same thing with running. Here is a sprinter. When the movement is too fast, the spacing between phases increases and can reduce the crossings. A simple slow motion allows us to highlight the tangents. Here is a cycle run. Another is an Aladdin's lamp run. The names cycle and Aladdin's lamp are better understood with cycles in place. Note that the sprinter's swing path is called La Poulaine, a name taken from a medieval shoe that it resembles. Obviously, when animating a walk or a run cycle, we do not start by drawing paths or tangents, but by imagining the main poses from which we derive the connecting paths. This allows us to imagine a wide variety of walks, far removed from those presented in this chapter. When playing this game, however, we must never forget to respect the knees limits, which, remember, bends backwards, never forwards. It is true that in animation we can do whatever we want, but here we'll never accept barbarism.